Before it ever built a single truck, this plant was building missiles. In 1953, Chrysler's missile division used this exact facility in suburban Detroit to manufacture weapons for the U.S. military. Today, it builds the second best-selling vehicle in America, and what happens inside these walls is unlike anything else in manufacturing. The Sterling Heights assembly plant sits on 286 acres in Sterling Heights, Michigan, about 17 miles north of downtown Detroit. 5 million square feet of factory floor. That's roughly 87 football fields under one roof. Nearly 7,000 UAW workers rotate through its shifts around the clock. And every single day, hundreds of Ram 1500 pickup trucks roll off its line and out into the driveways of America. Here's what most people don't realize. The Ram 1500 isn't just popular. It is a structural and mechanical achievement that gets more complicated with every generation, and the factory that builds it has been through more reinvention than almost any assembly plant in history. Missile production, car production, a $1.49 billion retool, an electric vehicle pivot, a cancellation, and through all of it, the trucks keep coming. We're going to walk every single step of how that truck gets built, from raw steel to rolling chassis, from paint booth to powertrain, from that iconic Hemi engine that starts its life 1,500 miles away in Mexico, to the moment a finished Ram 1500 hits the test track and gets cleared for delivery. Let's start at the very beginning, and the beginning is stranger than you'd expect. In the early 1950s, the United States government needed a contractor it could trust to manufacture ballistic missiles for the Cold War arsenal. It turned to Chrysler. Chrysler built a facility specifically for that purpose right here in Sterling Heights, Michigan, a sprawling, heavily engineered plant capable of handling the precision tolerances and classified work that missile production demanded. For years, this land was a weapons manufacturing site, not an automotive one. When the missile program wound down, Chrysler converted the plant to vehicle production. Decades of cars followed. Then, in the mid-2010s, Chrysler, by then part of what would become Stellantis, faced a hard commercial reality. The Chrysler 200, the mid-size sedan being built here, was dying. The American public had moved on from cars. They wanted trucks, Century. And Ram, the truck brand, was exploding. So in 2016, Stellantis made the call. Pull the 200 off this line. Spend $1.49 billion to completely retool this facility for Ram 1500 production. New body shop, new paint shop, new general assembly line, new everything. The overhaul took nearly 2 years, and on March 14, 2018, the first Ram 1500 rolled off the Sterling Heights line, a 2019 model year truck, marking the beginning of an era. Just under 7 years later, on April 16, 2025, the 2 millionth Ram 1500 assembled at this plant rolled off the line. A flame red 2025 Ram 1500 RHO. 2 million trucks in under 7 years. That's a number that takes a moment to fully register. And the story doesn't stop there, because in 2024, Stellantis announced another $235.5 million investment to prepare this same plant for electric vehicle production. The Ram 1500 REV, a fully electric truck, was slated to be built here, making Sterling Heights the first Stellantis plant in the United States to produce a fully electric vehicle. Then, in September 2025, the REV was canceled, after the $235 million had already been spent preparing the factory. The Ram Charger, a range-extended electric version that carries its own gasoline generator to recharge the battery on the road, survived the cut and continues in development. The Pivot, the cancellation, the $250 million already committed. It stands as one of the most dramatic industrial reversals in recent American manufacturing history. That's the plant's story. Now let's talk about the truck. The Ram 1500 is body-on-frame. That phrase sounds simple, it is not. Most modern passenger cars are unibody, meaning the body and the structural frame are the same single, stamped and welded unit. When you build a unibody car, you weld up the entire body shell, paint it, trim it out, and then push the engine and drivetrain up into it from underneath. The body never moves. The powertrain rises to meet it. A truck like the Ram 1500 works in the complete opposite direction. The ladder frame, a massive separate steel structure, is built entirely on its own, apart from the cab. You can't be sure that coming soon and Bocking and Truxture and First Stellantis planting construction is indeed well, if you are used for universal and lasting times and feature into the 297 clock. Well, to the Ram 1500 works in the complete opposite direction. The latter frame, a massive separate steel structure, is built entirely on its own, apart from the cab. 1500 works in the complete opposite direction. The engine, transmission, drive shaft, front and rear axles, suspension components, fuel tank, all of that gets bolted directly to the frame, which then rolls as its own complete rolling chassis. Only then, once that chassis is fully assembled and rolling under its own mechanical weight, the cab is lowered down from above and married to it. Then the bed comes separately, bolted to the frame as its own independent module. So the Ram 1500 isn't built as one unit. It's three: frame with running gear, cab, and bed. Each one engineered, assembled, and prepared independently before they come together. Assembled inside out and upside down compared to a car. And that body-on-frame architecture is what gives the Ram 1500 its towing capacity, its payload rating, its structural integrity under load. You cannot get to 11,550 pounds of towing with a unibody. The physics simply won't allow it. Keep that architecture in mind as we walk the line. Everything starts with steel. Raw coils of high-strength steel arrive at the stamping facility, each coil weighing thousands of pounds, and get fed into progressive stamping dies that cut, punch, and form the flat sheet into shaped panels. Hood skins, door inners and outers, fenders, floor pans, quarter panels, roof panels, each one pressed at pressures that would flatten a car. The 2019 generation Ram 1500 frame is 98% high-strength steel. When engineers redesigned it for that model year, they pulled roughly 100 pounds out of the frame alone, compared to the previous generation, while simultaneously making it the strongest frame Ram had ever produced. That sounds contradictory. It isn't. High-strength steel lets engineers use less material to achieve the same or greater structural rigidity. Thinner sections, fewer reinforcements, same strength, less weight. And in a truck where every pound saved translates directly to payload capacity and fuel economy, that matters enormously. The frame rails, the two long parallel steel beams that form the backbone of the ladder frame, are roll-formed into their characteristic C-channel or boxed shapes, then brought into the welding stations where cross members, mounting brackets, and reinforcement plates are added. Every weld point is load-bearing. Every bracket placement has been calculated against the forces this truck will encounter over hundreds of thousands of miles of use. By the time the frame exits the framing station, it is already a precision structural component, not just raw steel. Now comes the body shop, and this is where it gets genuinely extraordinary. The body shop at Sterling Heights is built around a concept called the open gate framer. 18 robots work in this station. 8 floor-mounted units, and 10 more hanging from overhead gantries. Their job is to hold every major body panel in its exact three-dimensional position and weld them together simultaneously. Not sequentially. Simultaneously. The precision here is measured in fractions of a millimeter, because every gap and surface that a buyer sees, every door jamb, every panel shut line, every seam is set at this exact moment. Get it right here, and the truck looks tight and precise when it's finished. Get it wrong here, and no amount of downstream correction will fix it. The door will never hang right. The gap will never close properly. The open gate framer is where the truck's visual quality is decided. 18 robots hold it there without flinching. Once the major structure is framed, the cab body moves into the rotisserie system. 36 robots. Here's the detail that stops people cold when they see it. The entire cab body gets flipped completely upside down. The whole thing, rotated 180 degrees so the floor faces up and the roof points toward the ground. In that inverted position, robots weld seams and apply structural sealants to the underside of the floor pan, the insides of rocker panels, the hidden surfaces that will spend the truck's entire life facing down at the road. Areas that would be completely inaccessible with the body right side up. 36 robots working the underbelly of the cab while it hangs inverted. Then there's laser brazing. 4 dedicated robots apply this technique along the joint between the body side aperture and the roof panel. Laser brazing uses a laser beam to melt a filler wire and flow it precisely along the seam. creating a joint smooth enough to require almost no grinding or finishing. It leaves a surface-quality joint on what will become a highly visible exterior line. The same technique appears on premium European vehicles. Not the obvious choice for a mass-market pickup truck. It is the choice you make when you want panel fit quality that punches significantly above the price point. The finished body in white, the cab structure before paint, is complete, welded, flipped, inverted sealed, laser brazed, and inspected. Now it needs color. The paint shop is one of the most tightly controlled environments in the entire facility. Temperature, humidity, airflow, all precisely managed. Paint adhesion, gloss, and long-term durability are catastrophically sensitive to environmental conditions. A single degree of temperature variation, a pocket of humidity, a particle of dust at the wrong moment. Any of these can produce a defect that gets traced back through the entire production run. The cab body enters the paint process clean. First comes the phosphate bath, a chemical treatment that creates a microscopically rough, reactive surface on the bare steel, giving the subsequent primer something to bond to at the molecular level. Then the cab goes into the electrocoat tank, where it is literally submerged in an electrically charged primer bath. The electrical charge pulls the primer coating into every cavity, every box section, every hidden pocket inside the body structure. Surfaces that a spray gun could never reach get coated. It is the most thorough corrosion protection a vehicle body can receive, and it is invisible, buried under every subsequent coat of paint. After the e-coat comes the sealer, applied by robots along every weld seam and body joint. Then the primer surfacer, which fills microscopic imperfections in the steel and builds a smooth, consistent foundation. Then the base coat, color. Then the clear coat, the glossy protective top coat that determines how the truck looks under a dealership's lights or on a highway at noon. Each layer is cured in an oven. The entire paint process takes hours. When the cab finally exits the paint booth, it carries one of the most durable automotive paint jobs in the segment. The truck will spend decades in American weather, ice and salt in Michigan winters, UV radiation in Arizona summers, humidity in Florida year-round, and the paint process is built to outlast all of it. With a freshly painted cab moving down the line, attention turns to what will power it. The 5.7-liter Hemi V8 does not begin its life in Michigan. It begins roughly 1,500 miles away in Ramos Arizpe, Coahuila, Mexico, at the Saltillo North Engine Plant. That facility opened in 1981. It covers 1.2 million square feet. In its history, it has produced more than 15 million engines. The Hemi is its flagship product and has been for decades. At Saltillo, machined aluminum cylinder heads are fitted to a cast iron block. The crankshaft, forged steel, is lowered in and its main bearing caps torqued to specification. 8 connecting rods and 8 forged aluminum pistons follow. The camshaft goes in. Valve train hardware, timing chain, oil pump, water pump, intake manifold, fuel injection hardware. The engine is assembled as a complete long block, tested on a run-in stand, then crated and loaded onto a truck. That truck drives north, across the US-Mexico border, up through Texas or New Mexico border, up through Texas or New Mexico, into the Midwest, all the way to Sterling Heights, Michigan. When the Hemi arrives at the assembly plant, it has already traveled the length of a long American road trip before it ever turns a wheel in a customer's truck. The 5.7-liter Hemi displaces 5,654 cubic centimeters. It produces 395 horsepower at 5,600 RPM and 410 pound-feet of torque at 4,000 RPM. Numbers that would have been considered serious performance figures a generation ago. In the Ram 1500, they are the base of the Powertrain lineup. And on the trucks equipped with eTorque, the Hemi gets considerably more interesting. The eTorque system is a mild hybrid setup, and the details of how it works are genuinely clever. On the Hemi V8, a belt-integrated starter generator replaces what used to be a conventional alternator. That unit is connected to a 48-volt, 430 watt-hour lithium-ion battery pack made by LG Chem. The whole battery pack weighs about 30 pounds and mounts at the rear cab wall, low and out of the way of cargo space. When the truck launches from a stop, the eTorque system fires the starter generator as a motor, feeding energy from the 48-volt battery into the belt drive and delivering an additional 130 pound-feet of torque instantaneously, on top of what the Hemi is already producing. That torque surge at launch is particularly useful when the truck is loaded or towing. Exactly the conditions where drivers need the response most. When the driver lifts off the throttle or comes to a stop, the system works the other direction. The generator harvests energy from deceleration and recharges the battery. A closed loop that constantly moves energy back and forth between the mechanical drivetrain and the battery pack. But the number that makes engineers quietly proud is this one. When the truck's automatic stop-start system shuts the engine off at a red light, the eTorque system can restart that Hemi V8 in 70 milliseconds. 70. Your blink reflex takes somewhere between 150 and 400 milliseconds. The engine is running again before you've finished blinking. The restart is so fast and so smooth that drivers who don't know the system is there often don't notice it happening. The fuel economy benefit across city and combined driving clocks in at 2 to 3 miles per gallon. Not nothing on a vehicle that sees heavy daily use. Now both the engine and the painted cab are ready. The frame is rolling. Time for the marriage. The chassis marriage, the moment the cab meets the frame, is one of the most visually striking moments in any truck assembly plant. At this point, the frame is already a complete rolling chassis. The Hemi, or the Hurricane 6-cylinder, has been mounted to the engine cradle and bolted to the frame. The transmission is in. The drive shaft connects through to the rear axle. The front axle and independent front suspension are fully installed. The fuel tank is strapped to the frame. Brake lines are run. The exhaust system is roughed in. Every piece of this mechanical assembly, thousands of individual components, rolls forward on its own wheels, fully capable of being driven. Above it, suspended on the overhead conveyor, hangs the completed, painted cab. Workers on both levels prepare the mating surfaces, align the cab mounting bolts to the frame's threaded inserts, confirm the orientation, and the cab begins its descent. It comes down slowly, millimeter by millimeter. The 4 body mounts, thick rubber isolators that both secure and acoustically decouple the cab from the frame, align with their counterparts on the frame. Contact. The bolts thread. Torque guns run each one to its specified value, and the two halves of this truck become one. Every Ram 1500 owner has experienced the quietness of that cab on the highway, the way it isolates from road vibration and powertrain noise better than most body-on-frame trucks have any right to. 4 rubber body mounts are the mechanical reason the Ram 1500 drives with a refinement closer to a luxury SUV than a conventional pickup. The engineers knew exactly what they were doing. The bed comes next. Unlike the cab, the bed bolts directly to the frame at 6 mounting points without the rubber isolation layer. It needs to move with the frame under load, flex with it over rough terrain, handle the weight of cargo without the decoupling the cab demands. And the bed itself has an engineering detail that almost nobody expects. The side panels of the Ram 1500 bed are adhesive bonded, not resistance welded, not riveted, glued, with a structural aerospace-grade adhesive that runs along the mating flanges, creating a continuous bond line rather than a series of discrete spot weld points. The same joining philosophy appears in premium European vehicles, Audis, BMWs, Mercedes, where engineers choose adhesive bonding for its ability to distribute load evenly along the entire joint rather than concentrating stress at individual weld points. Cleaner exterior surface too. No weld dimples. No grinding marks. Just a smooth, continuous panel face. When someone asks what separates the modern Ram 1500 from cheaper truck competitors, most will point to the interior or the powertrain. The truer answer is in the details that can't be seen. Structural adhesive on the bedside panels, laser-brazed roof joints, and 36 robots welding the body upside down. The craft is in what the buyer never sees. Speaking of craft, the interior. By the time the married truck and chassis reaches the interior trim stations, it looks like a truck from the outside. On the inside, it is bare metal, wire bundles, and noise-dampening foam bats. The interior build-out is methodical and sequenced with an almost neurotic attention to order, because the wrong sequence means taking things apart to install what should have gone in first. Wiring harnesses go in early. The main harness, which on a fully optioned Ram 1500 can include hundreds of circuits and thousands of individual connections, gets routed through the cab, clipped to retention points, and connected to junction blocks. Every module that controls everything from the transmission to the heated seats runs off this harness. One circuit wrong, and the symptom might not appear until a dealer diagnoses a fault code 2 years after the truck leaves the plant. Insulation follows. Headliner. Carpet. The HVAC system, the entire heating and air conditioning assembly, drops into position as a pre-assembled module and connects to its ducting system, refrigerant lines, and control wiring in one shot, rather than being built up piece by piece inside the cab. Then the instrument panel on the Ram 1500 Limited, the range-topping trim, that panel carries a 14.4-inch Uconnect touchscreen, one of the largest in-cab displays in the truck segment. A 10.25-inch screen for the front passenger, 19-speaker Harman Kardon audio with a subwoofer mounted behind the rear seat, dual wireless charging pads, heated, ventilated, and massaging front seats wrapped in quilted Nappa leather. All of it is assembled, wired, and tested before the seats go in. The seats are the last large items in. Front buckets or bench, depending on configuration, slide onto their floor track rails, the wiring connectors click home, and the bolts run down. Then glass. Windshield robots apply the bonding adhesive in a precise bead pattern and set the glass with enough accuracy to hold dimensional tolerance. Same for the rear window. Door glass follows when the doors are rehung. Doors that were pulled early in the build to give workers access to the interior come back at final assembly, fully glazed, weather stripped, and adjusted. And the doors bring us to a number worth sitting with for a moment. More than 63% of Ram 1500 parts are sourced from the United States and Canada. The truck is marketed as American. It is, in all the ways that matter structurally and economically, predominantly built from North American content. But the Hemi V8 comes from Mexico. The eTorque battery pack comes from LG Chem. Some electronic modules come from suppliers in Asia. The global supply chain is threaded through every square inch of this truck, whether the marketing acknowledges it or not. And those 63+% figures don't mean the other 37% is negligible. In a vehicle with thousands of components, every supplier represents a decision, a negotiation between cost, quality, proximity, and capability. The supplier base for a full-size truck spans dozens of states and multiple countries. When a parts shortage hits, as it did catastrophically in 2021 with semiconductor chips, the entire assembly line can stop dead, not because of anything wrong at the plant, but because a single component the size of a thumbnail didn't arrive on a truck from overseas. The Ram 1500's complexity runs deeper than how it's assembled. It lives in the impossibly long chain of decisions and dependencies that all have to line up perfectly for the finished truck to exist at all. With the interior complete, the truck moves through the fluid fill stations: engine oil, transmission fluid, differential fluid, coolant, brake fluid, power steering fluid where applicable, windshield washer fluid. Each fluid has a spec, a fill volume, and a test. Coolant is pulled through the system under vacuum to purge air pockets. Brake fluid is bled to eliminate air from the lines. The refrigerant charge for the air conditioning system is measured to the gram. Then tires. The wheel and tire assemblies come pre-mounted and balanced from a sub-assembly area. The correct assembly for the truck's configuration, because a Ram 1500 on 20-inch wheels with a sport suspension package gets a different assembly than one on 17-inch all-terrain tires on an off-road suspension, is pulled and staged. The automated wheel mounting arms present each wheel to its hub, the lug nuts spin down, and a final torque check confirms each one. The truck is now complete enough to drive, but it doesn't leave the line yet. End-of-line testing at Sterling Heights is not a quick walk-around. It is a structured battery of checks the truck must pass before it can be released. Headlights go through an aiming check and are adjusted to specification. The alignment rack checks that the front wheels sit at the correct toe and camber angles. If they're off, the truck will pull and wear its tires unevenly, a problem the buyer would feel on their first highway run. Wheel end torque checks confirm every fastener on the suspension and brake assemblies. The water test booth seals the truck inside and subjects every body seam, glass bond, and door seal to a high-pressure spray simulating heavy rainfall. Any leak, no matter how small, generates a fault that sends the truck back for repair before it goes any further. Water intrusion builds on itself. A small leak at the windshield becomes a mold problem, becomes an electrical problem, becomes an angry warranty claim 2 winters after purchase. Finding it here costs far less in every dimension. The brake roll test loads the truck's brakes while it sits on rollers, confirming that braking force is balanced side to side and meets specification. Uneven braking can be felt immediately on the road and traces back to a fault that should never have left the plant. On vehicles equipped with the eTorque system, the 48-volt electrical system gets a full functionality test, the starter generator cycling through its charge and discharge modes, the battery management system confirming cell balance and state of charge. On trucks headed out with the available air suspension, each corner gets cycled through its full height range under load. Final appearance inspection happens under high-intensity lighting designed to expose any paint defect, chip, or contamination that made it this far without detection. An inspector walks every panel, horizontal surfaces, vertical surfaces, jambs, door steps. Any defect found here gets noted, assigned a correction, and the truck either gets repaired in place or diverted to a repair bay. So here's the question I want to leave you with. Stellantis already spent $235 million preparing this plant for full electric production, then pulled the plug on the REV. Was that the right call? Does the Ram Charger's range-extended approach make more sense for truck buyers than a fully electric Ram? Or should Stellantis find a way to bring the REV back? Drop your answer in the comments. I want to know where you stand on the electric truck debate. If this kind of deep manufacturing coverage is what you're here for, hit that like button and share it with anyone who thinks trucks are just transportation. Because after watching this, they'll know better. Make sure you're subscribed, because next time we're going inside another American factory where the numbers are just as staggering and the process is just as extraordinary as what you saw today. The 2 millionth truck was flame red. Seems fitting for a plant with a history like this one.